Okay, so in this class, we are going to learn about how to build a retrieval system. We have to build a retrieval system. Okay, so a retrieval system is we have set of data. Okay, this is the requirement that we have a set of PDF data. Okay, we have some PDF data, and in the
Okay.
PDF data, let me show the data. I have the data ready. Yeah. So this is a PDF data. Okay. And in this PDF data, it is more like a questions answer. It's a frequent question answer. So it is about hotel industry. Okay.
Okay.
So in the hotel industry, they suppose they have some frequent common questions and their corresponding answer. For example,
Okay.
what is the time check-in? What is the offer? What is the breakfast? These are all things. Okay. Suppose you're building a chatbot.
Okay.
Chatbot, user can interact with the chatbot and they can ask any questions and chatbot can respond those questions. Okay, so here I have set of questions. Okay, so I have to build a system where if I give any keyword, for example, suppose I give a keyword like check-in checkout. This is my keyword, search keyword. Okay, if I
Okay.
give this search keyword into my system, then my system should bring this text information.
Okay.
Got it. So I have to build this system that my system will accept any keyword, and based on the keyword, whatever the data they have regarding that keyword, similar keyword, okay, they will fetch that data from the my system. So that is
But
what I have to build
mm,
retrieval system.
but here again, check and check out is already mapped in the second question also, right? So you should produce this one result or multiple. If you go back to the fact, right? Second question also has the word check in check out.
Yeah, so it will bring all the data which are similar.
Okay. Okay.
So for example, if I give check-in, so check-in is also here. It is
Mm.
also in this context also. It is also here. So
Okay.
whenever they find multiple occurrence or multiple keyword for that data, that keyword, it will bring those elements.
Okay.
Let me explain that. Okay, so
Sure.
that I would do here. So it is called similarity search. Okay, this concept is called similarity search.
Okay.
It's called similarity search. We will learn in next module when we start RAG application or RAG module. So we will run in advance what is similarity search. Okay. So it's a part of RAG basically. Here I mean whatever we are going to do here, we are going to do it manually.
Mm.
There's some different library for that. You don't have to do it manually, but here we try to simulate some couple of cases. Okay. So here what I have to do. So I have a so how this system will work. So I have a PDF document. This is my suppose this is my document PDF document. Okay, and this document has some certain questions answered, some keywords, some questions answered. Okay, and this is a user here, and this user will send some keyword, something,
Mm.
some word, some sentence, some keyword. Okay, and I have a system here. This is my suppose this is my retrieval system. This is my IR, information retrieval system. So this system will accept the keyword, and from this keyword, it will try to find out that this keyword, I mean, how many there are how many pieces or how many occurrence in my documents where this keyword is matching.
Okay.
It can have multiple occurrence. Suppose I got this occurrence, I
Yeah.
found multiple occurrence. Okay, so I need to pull multiple chunks of data which
Okay.
are matching with this keyword. It is called similarity search. We are not exactly matching the keyword. We are trying to find which are similar to that keyword. Okay,
Okay.
so we have to perform that search, similarity search, and we have to bring those list of chunk of document which are matching.
Okay.
This is the system I need to build. Okay, so how to build this system? So this is the design idea. How to do it?
The
We
search
go.
should happen in both question and answer, right? Or only in question part.
It can happen in all occurrences. And
All
suppose
okay. Okay.
in the question here, it will match here also. It will match here also. So
Mm.
whatever, suppose I give check-in this keyword, okay. So whatever the chunk, whatever it has a occurrence, so it will match those piece of chunk. Here will match here. It will match here. It will match here. It will match here also. It will match here
Mm.
also. Okay. So it will match. I think in this whatever data is, it will match this piece of
Mm.
that you have to bring from that keyword.
Okay. Okay.
Okay. So how to build this? Uh, how to build such system using generative AI? That's we are going to learn. Okay. So how to build such system? So what is the process here? Okay. So we cannot perform typical kind of keyword search or typical type of database search. Okay. Because in database, in the typical database, what happened? In the typical database, we have like we have a table, right? Suppose we have a table row, right? We have a column, right? And in typical database, what we do, we let's suppose we want to search something, then we do a keyword search. Suppose city, okay, city is equal to Bangalore. I want to search something which row has a city is equal to Bangalore. So we have a SQL, MySQL system, SQL system where we perform database query and we do keyword search. This is basically it is matching, exactly matching. Okay, so such system, such retrieval system is not based on keyword search.
Yeah, because it's all based on structured data, right? Whatever data you see is unstructured data.
Unstructured, yeah, this is unstructured data. It is not a formatted or structured data. Okay, so in that case, what we have to do, so this is the process. Okay, so first is called, so how this system work. Okay, so I hear my data, my input. My input is not a structured data, it is unstructured data. I'm playing with unstructured data, which can be PDF here, for example, here. Okay, and it has no any predefined format. It is a PDF. Okay, so what we have to do here, the first thing we have to build called data ingestion pipeline. It is called data ingestion first. Data ingestion. Okay, so first thing, see, right now our system is not capable to read from PDF. From this source, it is not possible. Okay, so we first of all, whatever the data, whatever the text or information that the PDF has, we have to do data extraction first.
Okay.
Okay, we have to extract that this whatever the document, whatever text they have, we have to extract the document data from the document. Maybe we have to do some cleaning on this data. Okay, and in terms of if we want to perform, see, we have two types of search. One is the keyword search. Okay, exact keyword match search, which we are doing with the traditional databases. Okay, one is the semantic search. Okay, or similarity search. Okay, so in the similarity search, it is called we are not doing exact keyword search. In the similarity search, we call vector search.
Sorry, come again.
Vector search. Vector.
Okay, vector search.
It's the concept of vector. We will learn in later, but okay. So how this vector works? Okay, so let me talk about what is vector first. So if you know in maths, if you have read in elementary school, like what is vector?
Honestly, I don't know.
Okay, so vector, so vector is more like it has two things. Okay, give me example of, okay, for example, if I say velocity, speed. Okay, if I talk about speed, or if I talk about velocity, so speed and velocity has two components, right? One is its magnitude. Okay, if I talk about what is the speed, it can be 10 kilometer per hour, it can be 5 kilometer per hour, it can be 2 kilometer per hour, any. Okay, so we are referring some magnitude, right?
Okay.
We have some data, and in that data we have some magnitude, some quantity, some data, some measurement. Okay, we can perform some measurement. So that is the one part. Okay, and additionally, with the magnitude, with the data, we also have a direction. This is very important. For example, if I say velocity of my car, suppose a car is moving at the speed of 10 kilometer per hour at the north direction. Can I make this statement?
Yeah, understand.
Okay, so if I say this statement, then it has two components involved. First is what is the magnitude of my speed, and at what direction they are moving. Okay, so yeah, so something, whenever we can associate something with either magnitude or direction, then it is called vector. Okay, let me give more example. Like it can be speed, it can be momentum, it can be acceleration, or it can be let's suppose coordinate of any, suppose let's suppose there's a, suppose there's a car. Okay, so this is the car, and this car is, suppose this is a two-dimensional space. Okay, suppose x-axis, y-axis. It is moving. Suppose this is a car right now. Right now, when it is moving, okay, maybe it's changing its position. It is here right now. Maybe it will come here. It will come here. Come here. Come here. Right. So you can see that at every point, it has some magnitude. It is moving some with some speed, some values,
Yeah,
some
spin direction.
magnitude, and changing direction. It will come here, then will come here, come here, come here. So something vector is something which we can associate with its magnitude. It has some amounts of magnitude, and also it has some set of direction. It has some direction associated. So that is called vector. Okay. Scalar, on the contrary, we have a scalar. So scalar is something without, it has magnitude. Okay, it has magnitude, but without no direction. I mean, it's just a pure number.
Okay.
It's a pure number. Okay. No, it has no magnitude. For example, if I say sugar, what is the sugar price? What is the weight of sugar? I can say 10 kg of sugar. Okay, but right now I cannot think about any direction. Okay, so something which has some magnitude, some data, but maybe they have no any such direction. It is called a scalar, and something which has some direction, it has some vector.
Okay.
Okay, this is a very normal common maths. Okay. So now think about in this case. Okay, so how this concepts, whatever we learn right now for vector, okay, how this concept we apply in the semantic search or semantic or similarity search, how it is related. Okay, and these concepts are pretty much important for into generative AI also. So we will learn right now. I'm just giving a we will cover in the advance, but just giving some hint right now. Okay. Yeah. Let's suppose if I give you some example. Let's suppose I have some. Suppose I have two things. I have list of fruits. I have a list of fruits. Okay, and I have list of suppose animals. I have two different entities. One is a fruit, one is animal. Okay, and in the list of fruit, I have suppose apple. I have banana. I have orange, and so on. Okay, and in the animal I can have a tiger. I can have fox, elephant, something like that. Okay. So let's suppose you have this set of things. You have set of fruits, set of animals. It can be more things. Okay. And let's suppose if I give you a new keyword. Let's suppose if I say you beer. Or let me make it simple, like dog. If I say your dog, this is my keyword. Okay. So as a human, this dog, where do you find this dog can be more closer to animal set of things, those set of entity or fruit set of entity? This keyword is more where it is more similar.
Definitely, as a human, I can easily interpret. No, it goes from animal.
It's animal, right? So how the machine will interpret this? Okay. So in order to interpret by machine, how we machine understand. So here these all words like fruits, like animal, like apple, banana, orange. Okay, we can what the machine does. Machine convert these all keywords, all the words, all the sentences into a vector. Because machine only understand numbers. Machine don't understand word or thing. They understand everything in numbers. Okay, so what we do, we convert this all individual words into a vector. Okay, and this vector will contain two things, as I talk about magnitude and direction. Okay, so for apple, okay, so let's suppose I have a two-dimensional space. It can be multiple space, 2 dimension, 3 dimension, 4 dimension. Okay, but for the sake of simplicity, I'm using only 2 dimension. So let's suppose I have 2 dimension. I have x, I have y. Okay, and I want to represent apple in 2 dimensions. Okay, I have an apple here. I want to represent apple in terms of 2 dimension. Okay. So in terms of 2 dimension, I have to think about what can be some magnitude. I have to assign some random magnitude, something like that, some numbers. Okay. So that I can represent apple as a number. Okay. So let's suppose I'm giving 2,4. In the 2 dimensional space, I'm giving some number 2,4. Okay. And at the same time, in 2 dimension, I'm also giving some direction, some angle. Okay, so this text apple, I can represent in a number using some magnitude, and I'm giving some, and into a space where it can be located. I want to locate this word into 2 dimensional space somewhere. Okay, maybe at random I'm doing some initialization. So let's suppose here suppose at this point I'm representing apple at this point of time. At this point, okay. So at this point, it has some. If I see from x y, it has some set of direction. This is an angle. It has. This point is located at some direction. Okay, and this point has also some magnitude. Suppose it is 2,4. So x along x it is direction 2, and along y direction 4. Okay, so it has some magnitude like that. Okay, so this point is representing. I'm representing this point with some set of magnitude or some set of direction. And how I'm doing this? I'm doing this. Let's suppose I have a model. Okay, how I'm doing this? Let's suppose I have some ML model or some advanced model. Okay, this model I have trained on multiple data. Okay, and this model job is what? To present the text information into number. This is what the model is doing. I have built a model. Okay, so whenever I feed new data to this model, and this model will give me some magnitude of that text. I want to represent the text in terms of some number. That's what it is doing, and also along with some direction. Okay, so this way I can represent a set of words in terms of numbers and in terms of direction. You getting this concept?
ML model is going to transform into
yeah, ML model is going to transfer. Suppose let's pretend that I have an ML model. Let's suppose this is a model. Okay, this is a model. Suppose it's a black box for you. Okay, this is a model, and this model is taking one text data. Okay, and for this text data, I want to get a corresponding numbers information. I want to convert this text into number format. Right. For example, we can convert, right? We can convert anything into number representation. Okay. So this text data I want to represent, suppose in 2 dimension. I'm using just 2 dimension only. So I want to represent this text into some x coordinate and y coordinate. Suppose I'm giving 4,2. Suppose this is apple. This text is apple, and for this apple fruit, it has assigned some number, some coordinate, 4,2, and some theta, some direction. This model is doing that. Okay, how this model is doing? Because I have trained this model, I have given the teaching, or I have given the training to this model that if it is apple, okay, you use some logic behind that. How this apple is getting converted into numbers, into XY coordinates. I have some logic. I have some algorithm behind that. I'm not going into that depth. What is the algorithm? But let's suppose there are some algorithms, some logic, some set of rule. It can be rule, it can be algorithm. Some set of rule are there which the model is learning, and based on that rule, it is converting the text into coordinates and some angle. This is what it is doing. Okay, you get this point?
Yeah, understand.
Let's assume that for time being we have some model which is doing this.
Okay.
Okay, and that is what like model like a llama model, like model like OpenAI, model like cloud model, they what exactly does the same thing. They convert this text into
coordinates. What you mentioned at 4,2 an angle, that is a vector value, right, for this apple?
Yeah, because if I have a magnitude and direction, then I can convert into a vector, right?
Okay.
So I'm converting this text into x coordinate, y coordinate, and along with some direction. I'm converting this text into a vector.
Okay.
So let's suppose I have this model, I have a bigger training, and this model is able to do that. Okay, so there are a lot of model right now, like it is called embedding model. This kind of model is called embedding model. Okay, so there are a lot of embedding model from OpenAI, from cloud, from Google, from okay, a lot of embedding model, a little open source model. So these kind of things are already possible. There are a lot of embedding model. What the embedding model does, it will take input, okay, text, and it will convert into vector. It will give you multiple dimension representation along with some direction. I have taken only 2 dimensions. It can have 1,000 dimensions. Okay, more than 1,000, 2,000 kind of dimension. It can, I mean, this model can represent any text information into multi-dimensional space. How that does, we will learn later on, but this is what the embedding model does. You getting this point?
Okay.
Yes, for time being, just pretend that there's an embedding model. And this embedding model, what they do, they convert the text into vectors format, multiple dimension format, multiple coordinate. Okay, so that's what I'm trying to do here. So I want to represent apple into some vector format. Okay, let's suppose I have mango. Suppose mango I'm representing here. This is for apple. This is for mango. Suppose I have a grape. So grape is coming here. Okay. So this is coming from the model. They are producing some embeddings. They are producing vectors like this. Okay. This concept you get it? Understand what is embedded and how? I know that I'm not going in the deep what is the model working, but just assume that there's a model which is converting the text into vectors. Okay. So let's suppose I have this vector presentation. This is my x dimension and y dimension, only 2 coordinates I'm using right now. Okay. And let's suppose I want to represent fruits, all the fruits. Okay. So suppose one fruit is coming here. Let's suppose this fruit's coming here. One is apple. Okay. Another fruit is coming. Suppose it's an orange. Orange is coming here. Okay. Another fruit's coming like orange, like mango come here. Another coming like papaya is coming here. Okay. So my model is giving embedding. It is giving my x and y coordinate, and I can have some direction also, right? I mean, at what angle they're associated. I can have a direction also. Okay. So it's creating a cluster of fruits over here. Okay. Now let's suppose I want to convert animals. I have a tiger. Suppose tiger is coming here. Just pretend. Let's suppose it is coming here by the model. Okay. And let's suppose I have a lion. Lion is coming here. Okay. I have a cheetah. Cheetah is coming here. I have a deer. Deer is suppose coming here. Okay. I have a dog. Dog is coming here. Okay. So it is getting a set of animals, set of clusters. Okay. Now, if we have this kind of embedding, this kind of arrangement, let's suppose we have this kind of arrangement, okay, and let's suppose if I give a keyword you, okay, that where is the elephant? I want to locate elephant.
In that case, if we feed the model, it gives the vector and it will go to the right cluster, right? Then we can find them.
So do you think elephant will be closer to this set of group or this set of group?
Yeah, right side. Yeah.
This set of group, right? Maybe elephant will come here, elephant will come here, maybe I don't know. But it will be very similar or very closer to this set of cluster. Right? So this way I can find that this, this new information, which is elephant, it is similar to this information. So I can say that this elephant, it is more, let's suppose this is a tiger. Okay. This is a deer. Okay. So I can, let's suppose this is a mango, this is orange. Okay. So can I say that this point or this elephant, it is similar to this point, and it is not much similar to this point because distance is very far away. This vector is very far away from this, the distance between this vector and this vector is very far away. But the distance between this vector is very less. So it's closer.
Yeah.
Okay. So this way I can identify that new keyword where it will locate, and I mean where it will get more similar kind of chunk, or where it is, I mean which cluster they will belongs to. Okay. Which, I mean where they will find more similarity with cluster, with keyword, with word.
Okay.
Okay. So that's what this retrieval system, I mean this is how the semantic search work. Okay. So okay, now let's come to our point PDF. Okay. So if you understand these concepts, okay, let's apply this concept. So let's suppose I have a PDF document. Okay. So in this PDF document, I have multiple text, right? Suppose I have for example, if I show you PDF, so this PDF has this set of document, right? This set of text. Okay. So what I can do, I have multiple sentences, right? I have multiple document, multiple sentences in this document, multiple sentences there, okay? So what I can do, I can take one chunk of data. Suppose I can take this chunk, this piece of information. It is called splitting. I can split, right? I can split this whole text into a set of words. Suppose this is my one split, okay? This can be a second split, okay? This can be third split, okay? It can be like this. I can get multiple split, right? I can do splitting, right?
Yeah, we can, but we can, as a human, we can split like question and answers, but how do we do in the case of logics?
No. Okay, I will come to that point. Is what I'm asking, can we do a split? Can I split this whole text into small chunks?
Yeah.
We can apply split function, right? Arrays, suppose we have a string, and from the string we can apply split function, right? So
we can.
So it will split the whole string into some chunk of data, right? So let's suppose this whole thing is a string. Suppose I'm loading this whole content in my Python. So this portion will be a string, right? And I can split this string by some sequence. I can split into some suppose by parenthesis, by comma, by something. I can split by some regular expression.
Yeah, in that case, we'll definitely get a chunk of words.
Yes. So is it okay, right? So from PDF, I can get set of chunks, set of list. So I'm getting list of text 1, text 2, chunk 2, or text 3, text 4, text 5. I can do that.
Yeah, we can.
Okay. So I got text 1, text 2, text 3, text 4. Like this, I can get multiple text. Okay. Okay.
The first chunk, right, or the entire file?
Yeah, entire file.
Okay.
So I load the entire file. This is my entire file. This is my whole text. I load the entire file in memory. Okay, using suppose open open library, right? Using file open, I can open it and I can load the entire word, entire content into my memory, and then I can apply some splitting, and I can get a set of chunks, set of text information. This much I think you got, right? This much I can do, right?
Yeah, we can do. Yeah.
Okay. Once I do that, okay, what I will do next, that for every text, for every piece of chunk, I'm calling it chunk, okay, or split or chunk, okay. What I can do, I have a model. Already I know that I already have an ML model, okay, embedding model, right? I explained, right, that this model can convert text information into vector. This model is there. We have a lot of embedding model like Google model, OpenAI, a lot of models are there. The model has already been trained that how to do the conversion. This model will understand. Okay, so I'm going to apply this model right now. Okay, I will take this model and I will feed. Sorry.
For each bit of word, we are going to apply the model.
Yes. So I have a model right now. Let's suppose this is my model, embedding model. Okay, this is my embedding model. So I will give each text, this chunk, every chunk individually to this embedding. It will go this every chunk will go into this embedding model, and for every T1 ke liye, I will get some set of vectors. Suppose V1, right? For T2, I will get some set of vector. For T3, I will get some set of vector. For T4, I will get some set of vector. For T5, I will get some set of vector. So I'm transforming my text information, text into vectors. This is okay till now?
Yeah.
Okay. So this text information now can be, I can represent this text information in some space, maybe X, Y, some space, because it's a vector. Okay. So it has some, suppose T1 is coming here. Suppose T2 is coming here. Suppose T3 is coming here. T4 is coming here. Let's assume it's coming here because this is coming from the model itself. Okay, T5 is coming here. Let's suppose it has some direction or some representation in the coordinates, right? So I got a PDF file. I loaded the PDF file. I got all the text. I converted the text into piece of information, piece of chunk using splitting. Okay, and then each chunk I convert it into embeddings, into vectors by using some model, and I can plot or I can represent those individual vectors into a space somewhere. It is possible?
It's possible. Since we have vector, we can map it.
Yeah. Now, if you understand here till here, okay. Now let's suppose you want to now user. So let's suppose you have list of vectors in your database. Suppose you have vector 1, vector 2, vector 3. You have list of vectors in your system.
Yeah.
Okay. Now let's suppose I'm getting new keyword. I want to perform some search. Okay, I'm getting some new keyword from the user. Let's suppose this is user, and they have given me new query or new keyword. Okay, let's suppose check-in keyword coming. Okay, now how I want to do some search. I want to check whether this check-in keyword, where they are very similar. It is similar to T1 where it is matching. It is similar to T1, T2, T3, T4, T4 where it is more matching, more similar. They are more closer. Okay. So how to do that? So I can convert again this query, whatever coming, I can again pass this to a model, embedding model, right?
Yeah.
I can pass to my embedding model, and this second keyword, what a query is coming, it will also get converted into another vector. Suppose V. Possible?
Yeah.
Okay. Now this V I already have a set of vectors as my source of data. Okay. I'm getting new V, which is my query. Okay. So here I can perform some search that I want to see that this vector, which is a new entry or new keyword or new query, this vector is closer to which vector, whether it's closer to T1, T4, T5, T5. It is called vector search.
Okay.
So I can perform vector search here, right? And if I find that, okay, so let's say I can find the distance. Okay, this vector, I can find the distance between vector V and T1, vector V and T2. I can find all the distances, right?
Yes.
Okay. I will get the list of distances, suppose D1, D2, D3, D4, D5. I get list of distances. So I mean D1 is for V and T1, and distance between V and T1. V and T2 is D2. V and T4 T3 is T3, like that. I got all the distances.
Yes.
Okay. And here in this distances, I can do a sorting. I can perform sorting, like sorting in terms of support decreasing order. Okay. So I will find that which has which distances are very which are more closer. Okay. If I find one thing, the distance always between two vectors, if you find the distance between two vectors, okay, the distance between two vectors lies between 0 to 1. Okay. Minus 1 to 1. Okay. The distance between two vectors lies between minus 1 to 1. Okay. If it is suppose I'm giving, for example, a distance between V and T1, let's suppose it is 1. Okay. It means that this vector is very close to T1 because distance is coming 1, so it's very closer. If it is coming suppose distance minus 1, okay, suppose in between V, suppose this is my T3, okay, and this is V1, so it's opposite. Minus 1 is for opposite direction, okay, and 0 is for it's the orthogonal. Suppose my V is here, and suppose T5 is here, it's orthogonal. Okay, so if the distance is very closer to 1, like suppose 0.9, 0.8, it is very close to 1, 0.7, 0.8, 0.5. Okay, so it means that 0.9, it means it's more closer.
Okay,
it's more closer. Got in this point? So this way I can find the distance, and I will find that what is the distance between my query and existing vectors. I will find the list of distances, and which is more closer to 1, and which is more closer to like 0.8 or something like that. I will do a sorting, and I will find that which is more closer. And out of this, I will take the top 5. Let's suppose I got top 5 vectors, which is the more closer.
Okay.
Suppose I got D2. Suppose I got top 3. I got D1, D2, D3. These are the more closer. Okay. So this way I can make a decision that this query is more closer to these 3 chunks because it's more similar, more closer. So that is my list of chunk, which is matching with this query.
Okay.
Got this, Funda? This is what is called similarity search.
Yeah, understand. But actually, what problem shape is different. No, we need to.
Yeah, this is okay. So this is my theory. This is the concept only. Okay. So this concept I can apply to solve my problem. How I can apply this to solve a problem? So this is the process. I'm converting. I'm loading my data. I'm converting into chunks. I'm converting my data. This is called data ingestion. This process, okay, this whole process which I'm talking about, this portion, this whole portion is called data ingestion process.
Okay. Okay. Yeah, because we are ingesting data in the system, right?
So we are building the data in a format where I can perform vector search. Right now on the PDF, I cannot perform vector search. Okay. So I need to convert all the data into vectors first, and then I can perform vector search. So this portion I have to do data ingestion first. So you have to build a model, where you have to build a logic in your program where you will load the document, you will get the text, you will apply chunking, you will apply splitting, and for each split, you will apply model, and you will get list of vectors. This is the first module.
I understand, but embedding the model, how do we do?
I will talk about that. Let's assume that it's a black box for you. We have some model right now. Let's assume that we have model. I will talk about that. Okay. So this portion is called data ingestion portion. So did you understand this portion, how you will build this logic?
Yeah, clear. Because basically we are extracting a text from the PDF and making it into chunks, and chunks will be converted to vector using the model. Clear.
Yes. So you have to use this model. How to use this model, I will talk about that. There are a lot of model available. I will talk about that. So here, as a in generative AI, we have a lot of model like chat, like OpenAI. There are multiple models. That's what we are going to leverage going forward.
But those models are large models, right?
Yeah, these are LLM. Yes. Yes, we can use that. It is not that it's called embedding model. Okay, there are two types of model. What is called text generation model. There are different categories of the model. Okay, for example, the model which I'm talking about here, it is not very large model. It is called, there are two types of model. One is called text embedding model.
Okay.
Text embedding model. So its size is not very large. Okay, one is called text generation model. Okay, so text generation model, I mean, you will give some query, okay, some question, and they will generate something. For example, chat GPT doing. So chat GPT, like Llama, whatever you use, right? Like Cloud, they are text generation model.
Responding with some answers.
Yeah, you giving some query, they will answer something. They will generate something. Okay. Text embedding is for converting the text into numbers, into vectors.
Okay.
We are going to use this text embedding model here for this work.
Okay, I understand.
Okay, so the first part to understand, right? First part, you have to build a logic.
Clear. Yeah, clear. Actually, currently we have a chunks of vector. That's
yes.
Understand.
Okay, so first you have to build a model for data ingestion. You got a back vector, so you will maintain a list of vectors, maybe in a program. Okay, this is the first part. Second part is the query part. Okay, so in every RAG application or generative application, we have two pipeline. One is a data ingestion pipeline, which you understand right now.
Yeah.
So we have to build a data ingestion pipeline in the program. This is what you have to do. Okay. So data ingestion will give you what? It will give you a list of vectors. Yeah. You have list of vectors. Like that. You got a list of vectors. Okay.
Why do you call it a pipeline? Because pipeline is the one which has multiple steps, over the.
It has multiple steps involved here. I'm not covering those steps, but it is not very straightforward that I load something, I convert into vector. In the between, there are a lot of things happens, which I'm not covering right now. We can do data extraction, we can do data cleaning, we can do conversion, lowercase, uppercase, special characters, emoji removal. There are a lot of things, like there are some hash, there are some special character, there are some @ there are a lot of things. We detect a lot of keywords and we remove it. We can sanitize something. Suppose it has some policy information, it has some SSN information, some secure information. We have to remove that. So a lot of things happens. Okay, so build a pipe. That's why we call it pipeline.
Okay, understand.
It's a step-by-step process. But right now we are just making it simple, just loading it, converting to check, and trying embedding. Okay, so this is the first part you have to build. Okay, using Python. Okay, and second part is a query model, query pipeline.
Okay. Okay,
query processing. This is your second module. Okay. So in the query processing, you will either can pass any query, any keyword, or suppose Q. I'm giving is Q. Okay. So you have to apply again embedding model. Okay, and from this key you will get another vector.
Yeah.
Okay, it's what you have to do, and then you have to find the distances. You will find the distances between this vector and this list of vectors. Find their distance. Okay, and
it will be saving in the memory, no?
Yes, you will save in the memory. This list of vector you have to save in suppose list in memory.
Okay.
You got the new vector, you got the new chunk, you convert into vector, and then perform the similarity, okay, and find the distance. Okay, so after similarity, suppose you build a function called def get similarity, suppose give something, okay, you're passing query, okay, and in the database you have already list of vectors, okay, and you perform similarity search, vector similarity, okay, and you get list of distances, right? And from this distances, we'll find that I want suppose top 3 elements which are closer. This is your search logic.
Okay.
Okay, and if you got the top 3, you got the top 3 vectors. Okay, you got top 3 vectors. Suppose given from this given list, okay, which you are maintaining. So from this given list, I suppose I got v2, v4, and v5. So these vectors are very similar to my query vector.
Okay.
So this is my, I think I'm interested in this chunk because they are matching, right? For this query, it is matching with this query, this vector. So for this vector, I have a text representation. It's a T2, it's T4, it's T5, right?
Do we need to maintain the mapping for this?
This is your logic. You can maintain a mapping. So for T2, I have a corresponding vector. For T4, I have a corresponding vector. For T5, I have a corresponding vector. And after the performing search, I got list of vectors which are very close. And for this vector, I need to convert into another text because I have a mapping. So I understand that for this query, which are similar, T2, this chunk, this thing are similar. And that is your result, final result. This is called IR system, Information Retrieval System. This is what you have to build.
But we are not complete, no? Because currently we have only vector. The output of this query step is just vector. Like,
no, output of this program will be a list of chunk, list of document, list of chunk. Because you will convert, you got vector, right? So you can convert this vector into chunk, right? You can get T2, T4, T5, right? Because you do a mapping. You have a mapping for each chunks who's a corresponding vector. So know that, right?
Yeah, I can. But one thing, when we pass the entire PDF, right, it will convert to a single word, no? It's not for each word we'll have to create a vector, right?
No, you will not get each word. You will get set of. If you apply chunking, if you apply splitting, okay, you can apply splitting by okay. So how there are multiple ways to apply splitting. Okay, you can do a suppose I will take suppose 100 character. In one chunk, I will take 100 character.
Okay.
So suppose it has 100 characters. So
line breaks.
Line break will contain include there. Okay. So suppose I have a rule. Okay. So while chunking, while creating a split, I have some predefined rule. Okay. That is up to me. Suppose I have a rule for splitting rule that you have to define. Okay. Splitting rule. That in every split, I will take suppose 100 character, 100 char. This is it. I have defined this rule. Okay. So according to this rule, so I will come to know, okay, what is the 100? So I will count from here. Okay. Suppose this is first character, second, third, like that. I will count till 100. Suppose till the 100, I got this much. Suppose I got this much. This is my first chunk, which having the 100 character. Okay. Next, again, I will start from here, from E. Again, I will count next 100. Suppose it came here. This is my second chunk. Next, again, I will count 100. So it will suppose it came here. Suppose till here. Suppose till here. This is my third chunk. So like that, you have to count. You have to keep counting 100 chunks, and you will get some set of text, set of information like this.
Okay.
Okay. So you can define some, characters that how much you want to contain in the split. Okay.
Okay.
You got this. You can define a rule that I can take 100 character, 200, whatever.
Okay.
Okay. Yeah. So there are two. So there are two things. One is the data ingestion. First, you have to build data ingestion. Okay. I mean, load the data, do apply splitting with some character, convert into get list of text, convert into vectors, maintain the vector, maintain the mapping. This is my text, this is my corresponding. Those things you have to implement, and then query processing, get a query, then again apply embedding vector, and then do search. Okay, similarity search. You got the overall concept, overall idea.
In the last step, right, in the query process stage, we are getting the query and finding the vector by using the embedding model. That's okay.
Yeah.
Next step is finding a similarity. That part, how do we?
Okay. So there are two things, similarity. Okay, so you got the vector, right? And from this vector, you want to find
From
the
the query, I have
similarity.
the vector, and also I have parallelly vector for all the chunks. Now, to find the similarity, any logic or
Yes. This is a valid question. Okay. So how to find the similarity? This is a very question. So again, let me repeat. So you got T1, you got a list of the split T1, T2, T3.
yeah.
You got this text. You convert it into vectors also, V1, V2, V3, V4 also. Okay. And you got a query, suppose V, this is a query, and you want to get the similarity. You want to find the distance, right? From V versus V1, you want the distance. V versus V2, you want the distance. V versus V3, you want a distance, right? You want the similarity, right? So for that, we have already, though we haven't studied that, but you can use that. It is called, we have a NumPy, okay? NumPy, you can use that library. So NumPy has a called similarity search, okay? So that you have to use this library from NumPy, okay? And second thing you have to use embedding model. So here maybe two things you don't know, how to use NumPy similarity search. I mean, how to find the distance between these two vectors, okay? That you have to understand using NumPy, and how to use embedding model. These two things you have to explore, okay? I think suppose assume that you know these two parts, then I think remaining parts is a pure Python part.
Okay. Because the challenge lies in the usage of embedding, right? Embedding and similarity.
Yeah, I will talk about it. But let's assume that you know that part. You know these two are unknowns for you. I know that. But let's assume that you know these two parts. But remaining part, do you find any challenge?
One more question. Suppose I'm reading the PDF and finding a chunk of 100 characters, right? The 100 characters is complete one set, no? One set of characters.
Yes, one set of characters.
But I need to find a mapping. Definitely, I'll pass the mapping to the embedding model and get the vector. That's okay. But how do we maintain this as a data structure? Can I go with the dictionary to
You can go with dictionary. Yes, you can maintain dictionary.
But our key is 100 characters, right? Can we hold such a big character?
Yeah, it can be. It can be a whole string.
But how do we find the uniqueness? Because there may be a chance that it may get clash and take it overdone, no? Not possible, but there is a possibility, right?
No, I think each chunk will be different. There's no possibility that everything and exactly everything is matching, because you are doing splitting right by chunk, right? So suppose this is one chunk, this becomes your one key in the dictionary.
Okay.
Second chunk is like this. So I don't think it will be exactly same. There will be some word, some different.
Because I'm thinking of a logic part where to keep the entire chunk as a key. I don't know whether it will work out or not for doing mapping.
It will work. It will work.
Okay, fine. But I understand the concept. So let me repeat what I understand.
Okay.
First, we need to pass a PDF and get all the characters as enter string. We have to apply a splitting rule. Splitting rule might be based on
character list, fixed character.
Characters or based on the paragraph. We can split the rule and find the chunk of strings. And chunk of strings. Then we need to use the embedding model,
right?
Model and produce the vectors.
Yes.
That is first part.
Yes.
Second step is query processing, where we have to accept the query and again use the same embedding model and find the vector.
Right.
And from this vector, we have to compare with, do a similarity search.
Right.
Do a similarity search for each vector and find the distance.
Yes.
And then sort and print the top 3 chunks.
Yes.
Okay, understand.
Okay, and for those 3 vectors, we find the corresponding chunks. That is the result.
Okay.
Now, question comes to, let me share that. 1 second. Now, question is about how to find the distance between two vectors, right? And similarity. Okay.
One more question.
Yes.
Assume that I'm having a mapping of a dictionary with text, the chunk and the vector.
Mhm.
Can you do a reverse lookup by passing the vector and get the chunk back in the dictionary?
Yeah, you can do that, but how you're getting vector, okay, from the vector, okay.
Because in Java, right, I used to have a DMap, bidirectional map.
Yes.
By passing key and get the value, or by passing the value and get the key.
Yeah, you can do a lookup. Even from the, you want to do lookup by value, right?
Yeah, lookup by value. Then only I get the chunk, right? Because my value will be the vector.
Yeah, you can do lookup. Yeah, I think you can iterate by items. You can get key value pair, and you have a lookup value and can do compare, right? You can do, if this value is matching, then you will take accept that pair.
Okay.
That filter you can apply.
Okay.
Okay. Yeah, how to perform similarity search? Let me give answer. Let me change this. Yeah, can you see my screen?
Yes.
Okay. So you just do a Google search, cosine similarity Python. Okay, you will come across this NumPy. Okay, so NumPy has a library called, you have to install NumPy. Okay, do pip install NumPy. NumPy is not core Python; it is a separate library. So in Python we don't have an array. Have you noticed that? In Python I have taught you list, dictionary, but I have not taught you array. So Python, core Python has no array. So that's what NumPy provide array functionality. It's if you want to create array in Python, you have to use NumPy. So NumPy is more like an array kind of data structure. Okay. So you don't have to go any advanced right now in NumPy. How does NumPy? Just you have to use this piece of code. It's very simple piece of code. So you have to use NumPy, and NumPy has a little algebra. We can perform a lot of mathematical calculation with the NumPy, like algebra, matrices, a lot of things. So here we are, this is a function, okay? It is accepting two vectors, okay? And these two vectors are, if you apply embedding, okay, first see your source is text, you got the text, right? From that text, you have to apply embedding, okay? Yeah. And the embedding will give you vectors, okay? So your input is a vector, okay? Suppose I have, this is my query vector V, and this is my vector 1, okay? I want to see the distance, okay? So how it is doing, converting the vector into array, okay? I got two array, A and B, and here okay, what is the maths here? The math is like this. In order to find the distance between two vectors, okay, there's a math, it is called cosine similarity. 1 second. So this is the math behind that to find the distance between two vectors. It is called cosine similarity. Cosine similarity. Okay. So we find like, cos theta is equal to A vector A dot vector B by dividing by magnitude of vector A and vector B. Okay, this is called cos theta. Okay, and this theta is called similarity. Okay, this is what we are calculating in the code object. Actually, we finding the dot product of two vector and multiplying by the magnitude. This is what it is doing basically. Okay, so we got two vectors. Okay, it is applying dot np dot np has a dot function. It is applying dot. It got the dot product here. Okay, then I'm getting a normalization. I'm getting the magnitude of vector A, vector B. Okay, and then I'm applying division. This is what it is doing, and it will give a distance. Suppose I have two vectors like this. Okay, I'm calling this, and it will give a distance. So this way you will find a distance between two vectors. You can use this piece of code. You can find on the internet, no problem. So for this, you have to use NumPy.
Okay. Other one about the
embedding model. Okay. There are more libraries. There's a scikit-learn library also for do SciPy. There are multiple library. Okay, to find that. So you just do a Google search how to find distance between two cosine similarity in Python. You will find out. Okay. Next thing about embedding model. Okay. So in order to use embedding model, you have to use either Google API or OpenAI API, some open source API. Okay. For example, right now you can use Google API. Okay, Google API is free. Otherwise, if you want to use OpenAI, then it's a paid one. So for Google API, what you have to do, you have to create an account into Google Gemini, Google API. Okay, this is a go to API key. I will share this link with you. Okay, so here you have to come. First of all, you have to create an API key, Google API key. Okay. If you create a Google API key like this, I have already some API key. You just create an API key like here, from here. Okay, give some name and it will create an API key for you. Okay, from this API key, once you have done, then you can create some embedding. There's some embedding models. Just search here Google embedding model. Okay. So you can see there's some embedding model. You can use this one of the embedding model. You can try this model. Okay. So once you create the API, okay. So after that, you have to install Google API. Okay. In Python, then you have to use this library. Okay, from Google Gemini client, and client give the model name. Okay, and this is your content. This is your text, bunch of text, T1, T2, and this will convert this text into embedding. You can try this. Okay. So this is what you have to do, and for this you have to get the library for Google. You need library for this. I think you have to import. Sorry.
In the code, what is showing, right? They are passing the starting the model, passing the chunk.
Yes, they're passing the chunk. Yes. So with this chunk, it will convert into vector.
Okay.
This is what you have to do. For this, you have to import library. If you want to use this, there's some library for that. Yeah, this is what you have to install. Google Gemini. Okay. So this is the Google SDK, Google library for using its Google API. So first you have to do this. Okay. And once you've done that, you have to get a key first.
Only one is
only one, this one.
Okay.
You install it. Okay. You first install it. You need a key for that. Create a key, and once you've done that, then you can use this code. What I showing that. You just
need a key.
Yeah, you have to pass the key here. Okay. Actually, it needs some. There's some environment variable Google API key. You have to pass that. Just to search how to pass Google API key to use Google embedding model.
Okay.
You have to do some research. I'm not teaching right now. Okay, I know that, but I'm giving some path. Maybe you have to do some research around that.
Okay.
This is what you have to export. Okay, you have to use your API key here. Okay, like this, and then see, this is the code is given here. You apply this. Okay, import OS. In the OS, create environment variable. Okay, this is the name. This is the key name, and this is your API key. Then import this, and then create a client, and from the client create embedding model. You see, I think this piece of code is there. Okay, so this is the piece of code you have to use. So you got embedding, you got a key, you got chunk of data, and this chunk of data you have to pass it, and you will get for every chunk of data you will get embedding. You got V1, V2, V2, V3, and for query also. Suppose you're getting a query also. This is your query. Again, you have to convert into embedding. So this way you will convert everything in vector. Your PDF document convert into vector, and incoming query also into vector, and then perform vector search. I show, right? Yeah, and then using NumPy perform vector search. These things you have to try.
NumPy we already saw. No? NumPy is only for calculating it.
In NumPy is only for array calculation, because you are using similarity search, right? The dot product, right? This is for this one. This is for this operation.
Okay.
This operation. So NumPy will help you to apply this operation. Dot product, finding the distance, similarity search.
Okay.
Okay, so I know that it is maybe the first time it is too much, I think, too much information for you, but it is not complicated. Okay, so it's not very difficult. If you understand the process, you understand the design, then it's not very difficult. So first, the design, data ingestion, query processing is all. You just watch this recording again. I will upload this recording. So this is what you have to achieve it. So
okay.
if you this is what we do generally in the generative AI, in the RAG also. This is all things which are going to do. We don't have to do this manually. We have library for that. For example, LangChain, Llama, there are a lot of library which does all the operations for you. Okay, but here I'm doing for everything from scratch.
You understand? I should know the basic state. What library is doing. Okay.
That's why I'm teaching you the basic, all the steps. This all thing will be abstraction over there. This library hide a lot of things.
Okay.
Okay, we are just doing everything from step by step.
Okay, sure. I'll note on this.
Okay, so I will share this couple of resources like cosine similarity, embedding, how to use embedding. You create account in Google API, okay, Google, and create a key, and then I will share the file, PDF file, and whatever we discuss, try to achieve it.
For reading the PDF, can we use any external library like Panda or?
No, right now don't use Panda. Just use Open, just normal Python.
Okay.
If you know Python, if you know Panda, you can use it, no problem.
No,
But I need only text. Whatever the text in the PDF, I just want to load into my memory, and I need to apply chunking over there.
Okay. The challenge is the normal library, right? Our open library will not.
It is not so rich. Yeah. You can use Panda if you know. You can try Panda, no problem. Open with Panda or load the.
I think it won't be nice to get the text from the binary file.
Yeah. Yeah, you try with Panda, no problem. Just find some Google code, somewhere. You will find a lot of resources there. Okay. So your job is load the first build a data ingestion pipeline, load the document using Panda, whatever, convert it into text, use some chunking strategy, some splitting strategy, create a list of chunk, apply embedding, convert into vector. You have to maintain a vectors, okay, mapping. This is your job. You have to maintain that. This becomes your this becomes your data ingestion pipeline. Second thing is a query processing. So accept any query, convert into vectors. Okay, perform vector search using NumPy. Create a list of what it called distances, sort it, and find which is the closer one, and that becomes your result. And for that vectors, find the corresponding text, and that's what you have to return key for this query. This is the corresponding list of chunks which are similar.
Okay.
So this is what you have to achieve.
Sure. I'll start work on that one.
Okay. And meantime, I will share 3 files with you: Pandatic and Fast API. Just go through the file. Okay, I think it's not very conceptual. If you know Python, then you will easily find it. Okay, next week I will complete all three topics next week. So next week you have a lot of tasks, a lot of assignments, complete CRUD operational things, and this search engine things, and go through.
Possibly, can you give some the PDF for this problem statement?
Yeah, I will give. Yeah, I will create a problem statement and I will share with you.
Oh, okay.
Yeah. Okay, this is all. I think if you have achieved this much, I think you're going good. So I think now you're you're understanding Python, all the ecosystem library. So I think you are making good progress. Okay. Yeah.
Okay.
Okay.
I can export the files, right? The 3 files from the lab for reviewing. Yes. And then meanwhile, you're going to share some information about the site, the keywords.
Yeah. I will share the file, the problem statement, and NumPy and Google API, those things. I will share those things.
Google API is free, no? Free of cost, right? Or,
Yeah, Google API is free. It has a paid version and free version both. So for your job, you can use free version. It will not charge you. But in OpenAI, it's not free. It's a paid version.
normally, in this case of people, I will try to restrict based on the user number of requests, right? I don't know.
Yeah, they have some quota. They have some restriction. They have some quota. But free one, I think you can use it. If it is
ask, we are going to use any library to invoke the API?
yeah, you have to go. You have to use the Google library, Google Gen I show, right? You have to install that library.
To make a request to Google API, right?
No, they will handle everything.
So it will internally handle.
Yeah, they will handle everything internally. You have to use their library, Google library. They will handle everything. How to invoke the model, both things they will handle.
Because definitely, if it is API call, then we need some REST API call.
Yeah, internally they are making a REST call itself.
So they will main dependency.
Yeah, they will maintain the call.
Okay.
That's why they're giving the SDK. So you have to just import the SDK. They will do all the stuff.
Okay, fine.
Okay.
Sure.
Okay. All right. I will see you the next Saturday. Okay.
Sure.
Okay.
Thank you.